Welcome to Lecture 7. In this lecture, we'll talk about finding the inverse of a linear transformation. And let's jump right into this topic. We'll look at problem 7.9.12. And the problem says the following. Find the inverse transformation show the details. And actually that's the instruction for those are the instructions for an entire set of problems. And so the first one in that set that we will look at is 7.9.12, and the given transformation for which we're supposed to find the inverse is the following. We have y1 is equal to 3x1 plus 2x2, and y2 is equal to 4x1 plus x2. Now the idea here is that these two equations define some linear transformation. We can call it L, and the way that we might draw a picture here is we'd say we have the vector x1, x2, and the linear transformation L will take x1, x2 to y1, y2. And y1 and y2 are given by this pair of equations right here. Now, what the problem is asking us to do is to find the inverse transformation, L inverse, that would take us back from y1, y2 to x1, x2. And so, one way of solving this problem is to simply solve for x1 and x2 in terms of y1 and y2. And then I want to show you another way to do this. So, the first way we'll do it is to solve for x1 and x2 in terms of y1 and y2. Okay, so let's think about how we might do this. If we multiply the top equation by 4 and the bottom equation by -3 and add, let's see what will happen. Well, first of all, let me go ahead, multiply. I won't add the equations together. I'll multiply the top one by 4 and the second one by -3 first. So if I multiply the top by 4, I get 4y1 is equal to 12x1 plus 8x2. And then if I multiply the second equation by -3, I get -3y2 is equal to -12x1 minus 3x2. And in case you're wondering why I chose those numbers for multiplying the first and second equation, you'll see why immediately when we add these two equations, because then the x1 terms will completely drop out, and it will be easy to solve for x2 in terms of y1 and y2. And then once we've done that, we can plug back in and solve for x1 in terms of y1 and y2. So let's see how this goes. When we add up the left-hand sides of the two equations, we will get 4y1 minus 3y2. And when we add up the right-hand sides, as we've already said, the x1's drop out, and we have 8x2 minus 3x2, or 5x2. And therefore x2 is equal to 4/5 of y1 minus 3/5 of y2. And that is part of the description of the inverse transformation L inverse. Now, to find the rest of the description of L inverse, we need to substitute this value for x2 into either one of these equations that we have up here, and then we can find x1 in terms of y1 and y2. So I'll substitute this expression for x2 into the first equation and see what happens. So we'll have y1 is equal to 3x1 plus 2 times 4/5 y1 minus 3/5 y2. And so we get y1 is equal to 3x1 plus 8/5 y1 minus 6/5 y2. And now if I take x1 to one side of the equation and leave the y1 and y2 terms on the other side of the equation, we'll get 3x1 is equal to minus 3/5 y1 plus 6/5 y2. And then if we divide each side of the equation by 3, we get x1 is equal to minus 1/5 y1 plus 2/5 y2. And that is an equation for x1 in terms of y1 and y2. And these two circled equations here for x1 and x2, they describe the inverse transformation L inverse. And that's how we would find the inverse of the original transformation L. Now, let me show you at this point another way that you could do this problem, and it's a little bit more systematic, and it also will give us a good way to check the work that we've just done. So we'll say check. Well, L could be described in the following way. L acting on x1, x2 is equal to y1, y2. We've already said that above. But now we know that y1 is 3x1 plus 2x2, and y2 is 4x1 plus x2. So we have this is equal to 3x1 plus 2x2, 4x1 plus x2 is the value for y2. And note that this can be written in this way. We could have 3, 2, 4, 1, x1, x2. Because if you multiply this matrix, 3, 2, 4, 1, by the column vector x1, x2, the first, when you multiply this row times this column, you'll get 3x1 plus 2x2. And when you multiply this row times this column, you'll get 4x1 plus x2. So this is another way of writing the column vector y1, y2. We write it here as a matrix multiplication. And when we compare now the left-hand side and the right-hand side of this equation, we see that we can identify this matrix with our linear transformation L. So this is the matrix representation of L and the basis that we're using here. And we want to find L inverse, and as you might guess, all we have to do is to find the inverse of this matrix. So, and we know how to do that, so let's just see how this will go. 3, 2, 4, 1, 1, 0, 0, 1. And so if we multiply the top row by 4 and the bottom row by -3, let's see what will happen. We'll get 12, 8, 4, 0. And multiplying the second row by -3, we get -12, -3, 0, -3. And now add the top row to the bottom row, we get 12, 8, 4, 0, 0, 5, 4, -3. And now we can let's see, I think I'll divide the top row by 4 first. In a different way, you know, different people would do this with different numbers of steps. And as has been the case in previous problems that we've done, I like to avoid fractions. So anyway, you know, you might do this differently, but I'll just show you the way that I would do it. So if we divided the top row by 4, we would get 3, 2, 1, and 0. And that doesn't affect the second row at all, so we still have 0, 5, 4, -3 there. And now if we multiply the top row by 5 and the bottom row by -2, let's see what happens. So we get 15, 10, 5, 0 when we multiply the top row by 5. And when we multiply the second row by -3, by -2, we will get 0, -10, -8, 6. And now let's add the second row to the first row, and we will get 15, 0, -3, 6. And on the bottom we will have 0, -10, -8, 6. And now let's divide the top row by 15 and the second row by -10. And so what will happen, we'll get 1, 0. Remember, we're dividing the top row by 15. So -3 divided by 15 is -1/5. And 6 divided by 15 is the same thing as 2/5. And then dividing the second row by -10, we get 0, 1. And -8 over -10 is 4/5. And 6 over -10 is -3/5. And now we have the identity matrix on the left-hand side. And so we conclude that the matrix for L inverse is -1/5, 2/5, 4/5, -3/5. And now to finish this up, so we have L x1, x2 is equal to y1, y2. And so if we multiply both sides of that equation by L inverse, we get x1, x2 is equal to L inverse y1, y2. And now if we substitute the matrix representing L inverse, we will get minus 1/5, 2/5, 4/5, minus 3/5, y1, y2. And so our final conclusion is x1 is equal to minus 1/5 y1 plus 2/5 y2, and x2 is equal to 4/5 y1 minus 3/5 y2. And that is a description of the inverse transformation. And let's compare that to what we had before. Notice right here we have x1 is negative 1/5 y1 plus 2/5 y2, and that exactly matches what we found for x1 down here. And then for x2 we have 4/5 y1 minus 3/5 y2. Same thing down here, 4/5 y1 minus 3/5 y2. So really I think that finding the inverse matrix is probably a somewhat more systematic way of doing this, but you can see from the way we did this that a lot of the same numbers and a lot of the same steps are coming up as what we did above. So however you wish to do this is fine. Either way can be used to find the inverse of a linear transformation. But let's just to make sure that this idea is clear, let's look at one more example. So let's look at problem 7.9.14. And the given transformation in this case is y1 is equal to 0.2 x1 minus 0.1 x2. y2 is equal to minus 0.2 x2 plus 0.1 x3. And finally, y3 is equal to 0.1 x1 plus 0.1 x3. So whereas the linear transformation in the previous problem was mapping two-dimensional vectors to two-dimensional vectors, this one is mapping three-dimensional vectors x1, x2, x3 to three-dimensional vectors y1, y2, y3. And again, we can say this is the linear transformation L, and so we're trying to find L inverse, which will give x1, x2, and x3 in terms of y1, y2, and y3. And again, there are multiple ways you could do this. You could go ahead and start fooling around with these equations to try to solve for x1, x2, x3 in terms of y1, y2, y3, or you could go ahead and take the matrix approach, and I think that because that is more systematic, I'll just go directly to that. So L is represented by the matrix 0.2 minus 0.1, 0.0, 0.0 minus 0.2, 0.1, 0.1, 0.0, 0.1. That is L. And if we want to find L inverse, then we know that over here we put the identity matrix, and then go through Gauss elimination until we get the identity matrix on the left-hand side. So let's see how this will go. Okay, and once again, I want to just stress that different people would do these things in a different order, but I'll just show you the way that I would do it. Okay, so what I would do first of all is because of all of these decimals, I would multiply every row by 10, and I would also switch the first row and the last row, because then I would have a 1 up here, and that's convenient. So we would get 1, 0, 1. This is switching. I'm taking the last row now, I'm multiplying it by 10, and I'm switching it up here to the first row. So I get 1, 0, 1, 0, 0, 10. Now I switched that with the first row, so let me go ahead and put the first row down here. We're going to multiply the first row by 10 and switch it with the last row. We'll get 2, negative 1, 0, 10, 0, 0. And finally, the second row, I'm leaving it where it is, but I'm multiplying it by 10 as well. So we get 0, negative 2, 1, 0, 10, 0. So this is what we have. And now I will multiply the first row by negative 2 and add it to the third row to get rid of this 2. So we have 1, 0, 1, 0, 0, 10, 0, negative 2, 1, 0, 10, 0. And when I multiply the top row by negative 2 and add it to the third row, we'll get 0, and then negative 1, and negative 2 times 1 is negative 2, and 0 is negative 2. Negative 2 times 0 added to 10 is still 10, and this is 0, and negative 2 times 10 is negative 20, and add that to 0 and we get negative 20. So when we multiply the top row by negative 2 and add it to the bottom row, this is what we will get. And now I would favor multiplying the last row by negative 1 and switching the last row and the second row. So we'll have 1, 0, 1, 0, 0, 10. And when we multiply the last row by negative 1 and switch it with the third row, then the second row becomes 0, 1, 2, negative 10, 0, positive 20. And again, that's happening because we're interchanging the second and third rows, and we're multiplying this row down here by negative 1. And then the second row now becomes the third row, 0, negative 2, 1, 0, 10, 0. And now it will be easy to eliminate this negative 2 simply by multiplying the middle row by 2 and adding it to the final row. So we have 1, 0, 1, 0, 0, 10, 0, 1, 2, negative 10, 0, 20. And then again, what we want to do here is multiply the second row by positive 2 and add it to the third row. So we have 0, 0, 2 times 2 is 4 plus 1 is 5. 2 times negative 10 is negative 20, and added to 0 is negative 20. 2 times 0 is 0 plus 10 is 10. 2 times 20 is 40 plus 0 is 40. And so this is what we have as a result of multiplying the second row by 2 and adding it to the third row. And now let's divide the third row by 5. So we have 1, 0, 1, 0, 0, 10, 0, 1, 2, negative 10, 0, 20, 0, 0, 1, negative 4, 2, 8. And we're getting close now. In fact, all we have to do now to finish up this problem is to add the negative of the final row to the first row to get rid of this 1, and the negative of the final row to the second row to get rid of this, actually negative 2 times the final row to the second row to get rid of this 2. So let's do both of those. Okay, so we're going to add the negative of the third row to the first row. We'll get 1, 0, 0 on the left-hand side, and when we add the negative of the final row to the first row over here on the right-hand side, the negative of negative 4 is 4 plus 0 is 4. The negative of 2 is negative 2 plus 0 is negative 2. And the negative of 8 is negative 8, and 10 is positive 2. Now we want to multiply the final row by negative 2 and add the result to the second row. So when we do, we'll get 0, 1, 0 on the left-hand side. And now for the right-hand side, negative 2 times negative 4 is positive 8, and negative 10 gives negative 2. Negative 2 times 2 is negative 4 and 0, negative 4. Negative 2 times 8 is negative 16, and 20 is 4. And then 0, 0, 1, negative 4, 2, 8. And therefore, now we're now done. We have the identity matrix on the left-hand side. And so we get the result that the matrix for L inverse is 4, negative 2, 2, negative 2, negative 4, 4, negative 4, 2, 8. And therefore, x1, x2, x3 is equal to 4, negative 2, 2, negative 2, negative 4, 4, negative 4, 2, 8, y1, y2, y3. And so our final answer is x1 is equal to 4y1 minus 2y2 plus 2y3. x2 is equal to minus 2y1 minus 4y2 plus 4y3. And x3 is equal to minus 4y1 plus 2y2 plus 8y3. And there is our inverse transformation. And if you'd like to check that, we can do so as follows. Okay, we have 4y1 minus 2y2 plus 2y3. And that would be 4 times, now up above, we have that y1 is 0.2x1 minus 0.1x2. 0.2x1 minus 0.1x2. y2 is minus 0.2x2 plus 0.1x3. Okay, minus 0.2x2 plus 0.1x3. And y3 is 0.1x1 plus 0.1x3. So plus 2 times 0.1x1 plus 0.1x3. Okay, and let's see what that will work out to be. Okay, we're going to have 0.8x1 here, and a 0, we don't get any x1 there. And here we have 0.2x1, so we have 0.8x1 and 0.2x1, so we get x1. What about x2? Well, here we have a minus 0.4x2, and here we get a plus 0.4x2, so that will cancel out, and there's no x2 term here, so we don't get any x2 term. And what about x3? Well, here we'll get a minus 0.2x3, and here a plus 0.2x3, so we don't get any x3 term either. So all we get on the right-hand side is x1, and of course that checks with what is on the left-hand side, x1. Now let's check x2. Okay, we have minus 2y1 minus 4y2 plus 4y3. So that would be minus 2 times 0.2x1 minus 0.1x2 minus 4 times minus 0.2x2 plus 0.1x3, and then finally plus 4 times 0.1x1 plus 0.1x3. And now let's check this. Okay, we get a minus 0.4x1 here and a plus 0.4x1 there, so no x1 terms on the right. What about x2? Well, here we get a negative 2 times negative 0.1, so a 0.2x2 plus a 0.8x2, so we get x2. And there's no x3 term here, but here we get a minus 0.4x3 plus 0.4x3, so no x3 term, and so we just get x2 on the right, and that matches what we expect. And now finally, this is looking good so far. Let's check the last one. Minus 4y1 plus 2y2 plus 8y3. And that's minus 4 times 0.2x1 minus 0.1x2 plus 2 times minus 0.2x2 plus 0.1x3 plus 8 times 0.1x1 plus 0.1x3. Now, for x1, we have a minus 0.8x1 and plus 0.8x1, so there's no x1 term on the right. What about x2? Here we have a positive 0.4x2 minus 0.4x2, so there's no x2 term either. Now finally, what about x3? Well, we have 0.2x3 and 0.8x3, and so that is x3. And all of this does indeed work out. And so that is how you find the inverse. We've looked at two examples now. One was the inverse of a 2 by 2 or transformation, let's say from R2 to R2, and the second one was finding the inverse of a transformation from R3 to R3. And so that, and we've seen here two different ways to find the inverse of a linear transformation. And we've discussed how to check your answer in both cases. So that's it for this lecture. And now let's consider some problems. So the problems that I'd like for you to look at for 7.1, let's do problem 7.9.11, and for problem 7.2, try the problem 7.9.13 from your textbook. And that is the end of the problem. So that concludes Lecture 7, and good luck.